Right now, 437 light-years from Earth, a solar system is being born, and it looks almost exactly like ours did 4 billion years ago. Astronomers have just directly imaged two giant planets forming inside a dusty disk around a baby star called WISPIT 2. The gaps they're carving, the distances they orbit, the sheer scale of it all, it's like holding up a mirror to the birth of our own solar system. WISPIT 2 is a startlingly young star. At just 5.4 million years old, it's less than 0.1% of our sun's age. And yet, it already has two massive planets in orbit. The system sits about 437 light-years away, inside a star-forming region of the galaxy. What makes this discovery extraordinary is that it's only the second time in history that astronomers have directly observed two planets actively forming at the same time inside the same protoplanetary disk. That's not a simulation or a model. That's real, live planet birth. The inner planet WISPIT 2c orbits at about 15 times the Earth-to-Sun distance, roughly where Uranus sits in our solar system. It's already a true gas giant in the making, and it's actively feeding, pulling in gas and dust from the surrounding disk, growing larger with every single orbit. Further out is WISPIT 2b, a genuine behemoth. It orbits at roughly 60 times the Earth-Sun distance, well out into what would be the Kuiper Belt zone in our own solar system. Its mass? Approximately 5 times that of Jupiter. These two planets aren't just big, they're gravitational architects, actively reshaping everything around them. Here's what makes scientists so excited. As WISPIT 2b and 2c orbit their star, their gravity plows through the disk, scooping out rings and gaps in the dust. Those gaps, their spacing, their depth, their structure, look eerily familiar. They mirror the kinds of features our own Jupiter and Saturn would have carved into our solar system's early disk. This is the best real-time snapshot we have ever seen of a process we only theorized about for our own origins. This isn't just cool space stuff. Understanding how gas giants form tells us something fundamental about why our solar system turned out the way it did, and why it might support life. Jupiter didn't just sit there quietly. It actively shaped where the asteroid belt formed, how rocky planets like Earth ended up in the habitable zone, and what the final architecture of the whole system looked like. WISPIT 2 lets us watch that same architecture being drawn up in real time. And this comes at a critical moment. Planetary scientists have been refining models of how gas giants grow and migrate, but real-world data is painfully limited. WISPIT 2 is a live laboratory. By tracking how 2b and 2c continue to interact with the disk over the coming years, astronomers can test and challenge the best theories we have, theories that reach all the way back to explaining our own existence. There's one more twist. The data hints at a third, still unseen planet, farther out, carving a fainter gap in the disk. If confirmed, WISPIT 2 could be on its way to becoming a multi-planet system with a structure even closer to our own. We are watching a solar system in draft form, and the draft is looking startlingly familiar. Discovering WISP-2 is like finding a baby photo of our solar system tucked away in the cosmic archive. It reminds us that our planets weren't a 1 in a trillion accident. Same pattern, massive gas giants forming early, shaping a disk, setting the stage for smaller worlds. It happened before, and we just caught it happening again, 437 light-years away. Somewhere out there, a brand new solar system is writing its first chapter, and somehow it's ours to watch. If this made you curious about how astronomers actually image these infant planets, the telescopes, the techniques, the raw data, drop a comment below. That story deserves its own video. Subscribe so you don't miss it, and I'll see you in the next one.